Oh, it's just in here. I don't know what it is.
Zach.
Silence. We're besties, right?
I don't even know what that was.
COVID boy. That's what happened.
Oh, no. 1988. I flew 4 women.
That was my finger. My finger got off.
Yeah, 1988. I flew 4 women in Louisville Hotel.
No, whoever put my finger in
You've never seen it happen. Too many animations. It's a good show. But you wouldn't understand.
Yeah, you're right, yeah. And you're literally the only one that's not even trying.
Why did I try to get my parents?
I gotta do that.
I've been watching it. I don't know you, but.
Why did you know?
All right. Can I show you guys this one yet?
No.
Here, I'll turn this way. Hopefully they can see that. If someone tried to make me dig my own grave, I would say no. They're going to kill me anyway. I'd love to die the way I lived, avoiding manual labor. So, don't give in to that. Somebody asks you to dig a grave. No, it's for you. Don't dig it. So, all right. All right. More good advice.
What?
Don't marry someone based on popularity or based on looks. Marry the one who loves math, because in 20 years, when your child comes home crying about geometry, that sweet nerd will be your ever-loving superhero. So this is good advice.
Geometry sucks. I'm sorry.
Also, good reason to marry somebody who loves math is they make a lot more money usually. Not me, obviously, but other people. People who are good at math make way more money than people who are not good at math, on the average. So marry someone like that. All right.
Because people who are bad at math don't understand how much they should be able to be. That's because people who are bad at math don't understand how much they should be paid.
That's right. Very good.
I said dog gun.
All right.
Fox gun.
So here's some actual good advice, Mr. Rogers. Knowing that we can be loved exactly as we are gives us all the best opportunity for growing into the healthiest of people. So this is helpful relationally. So when you love someone, love them as they are, not as how you want them to be. Love them as they are. But your love for them is the best way for them to grow. This is also true with the gospel. Christ has loved us as we are and died for us while we were sinners. And it's his love and it's the free promise of the gospel that gives you the power to grow in holiness. And so this is actually a good gospel principle too. So love Mr. Rogers. All right. We are going to talk about monomials. Let me turn this back this way. Oh no. Make sure that's working. Is that working?
And the top gun. I mean, the fox gun.
I will shoot you.
Do it. Rude is not afraid. I'm not afraid. Dude, I almost got that a couple years ago. I was in the store at Walmart. I love it. He's like, why are you so old? I said fox gun.
Wrong way.
Are you kidding me?
All right.
No, stay. Stay. Listen, Douglas. I didn't mean actually go. Hit it. You don't need it.
Okay. So.
Mr. Douglas.
Yes.
He left.
What's that?
He left.
Who left?
He wants a soccer ball, which will make him more annoying. And Doc took it. Honestly, Doc did the right thing.
You want to go to soccer?
Okay. So we were talking about monomials. Sorry, I got the wrong screen up for you.
Can't help you there.
I thought he'll get quiet.
I know you're
You guys.
Okay. First of all, what is a monomial?
Well, it's one something.
It's one something. Very good. A monomial is a mathematical term that does not have any addition or subtraction operations. That's a monomial. So if you have x plus 3, that's not a monomial. Do we know what to call that?
An equation.
It's actually an expression. There's no equal sign. It's a binomial. Two terms. Binomial. Okay.
Are monomials only things with no addition?
Monomials have no addition. So this is a monomial.
Oh,
Here's the crazy thing. So is this.
so is it like a sign makes it binomial? Like,
An addition or subtraction makes
That's
it
that's a quadnomial.
no. That's a monomial. It's a monomial. Because it doesn't have addition or
It's a
subtraction.
fraction.
That's still a monomial. That's a single term.
It's an ugly fraction, that's what that is.
It is. It's an ugly ratio, but yes.
Pretty nasty.
We don't know if it's a fraction or not, but it's a ratio. We call them fractions. Sorry, I'm trying to teach rational
You
numbers. So
disrespected Laura.
you didn't disrespect me. It's fine. I'm not trying to.
He said you disrespected me.
Oh, I just
No, I'm kidding.
No, I didn't. No, I'm not trying to be nitpicky either. Anyway, this is a monomial. Hopefully, we're not going to deal with anything quite that large, but we will deal with things that are this large by the end of the day today.
Oh,
So,
I did that by, not in biology, but in geometry.
yes, you probably did.
Last year, this was the barn.
So, I'm going to do something different than I did in the earlier class because they freaked out about the very first principle.
Yeah.
Okay, so I'm going to skip that very first principle and come back to it.
We're going out of order.
Out of order. We're going out of order. So, here's the first principle we're working on. We're learning about exponents primarily. Take them out of your ear. You have to listen to this. You have to listen to this. What? It's just music with that.
Oh my God.
Oh, unplug that. It's unplugged from his battery at least. Okay, stop. Don't touch it again. Don't touch it again. It's on the floor.
By your charger.
It's
Come
like,
on.
You're gonna take pictures of the word.
that's fine. This is also being recorded.
Oh.
Hey, stop.
Mr. Douglas, you farted.
Were you in here when Pauline was doing that the other day?
No.
Oh, you missed that.
David, I put David at it.
Laura.
We already done the foul.
What?
The charger's stuck in his phone.
You broke it.
It's stuck. So let's go.
I had one hand, you had two hands. Who's more responsible?
You're going to charge it.
It's your phone.
I'll fix it.
No, I got
Fired.
You don't know why.
I gotta take the case off and we don't move.
Be careful and leave it alone for now. You can do it later. So anyway, yeah, David was doing that to me. So Lindsay was on the screen, and so David was sitting right here next to this thing, and Lindsay had earplugs in. And so I bent over to pick something up, and David did that, and nearly blew her earbuds out. But,
Did she at least laugh about it?
oh gosh, we all did. It was fun. She was like this, you know.
I wish I was in there.
I can't believe, I don't want you, well, this is the day you got to go home
I
early.
was at work.
Yeah, they went home early. Usually you're here, but, all right. So for any real number A, an integer n, I want to say arbitrary, integer m and n, sorry, m and n,
M and N.
a to the m times a to the n equals a to the m plus n. So, okay, we're going to do this as an example because that'll make more sense. Because you look at this, you're like, that's all letters. What does that have to do with anything? But x to the fourth times x squared, what do you think that's going to be?
Like X is right.
X to the sixth is correct. It's m plus n. If the base is the same, you add the exponents when multiplying. Here's why. Let's say we write this in expanded form. X to the fourth is 4x's. Well, multiplication is both commutative and associative. You can just remove these, right? We got multiplication here. We can just take these. We don't care where they are. We can multiply x times x times x times x times x times x, and we get x to the 6. There's 6 x's, right? So that's why that's true. Okay? Everybody get that?
Yes.
Now, I think that you all are accepting this pretty quickly, which I'm glad the earlier class didn't accept it very quickly.
When, like, you're first looking at it, you're like,
Yeah.
but
It's just
It makes
exponent
sense.
rules pretty much, right?
Here's a, the entire day has been like this. I'm telling you.
I thought,
So-
that's what I was texting you about. I was trying to get him to bring it
I
back.
think it makes a lot of sense because
I kind of want to
It's
just like
pretty
run over there and
simple
go back at it. Just,
It really
it
isn't
really
bad at
is
all.
simple. Yeah.
But let's look at this. Let's try an example with numbers. 3 squared times
The other class had trouble with it?
3 cubed. No, not this part. It's even worse.
is it 9 to 5?
So, right now, we're pretty much just doing exponent rules.
Yes.
So I can go to
So 3 squared, that equals 3 to the 5th. Well, if you did that on your own, you'd go 3 squared is 9.
You have a tiny child waiting outside the door for you. That answers your question. Oh, I was supposed to take that. I wrote it in the back. I forgot. I don't want anything for your heart.
He's supposed to take
Yeah,
it.
it's, I'm supposed to
reduce
take it,
inflammation.
so it reduces inflammation. Yeah, but you know what? I don't
It's funny how
care.
I actually listen to what you say sometimes.
Don't touch him. That's Fred. What do you mean him?
Right, both come with
No.
What do you mean him? Remember Frederick? Your water bottle? Don't talk about
I'm not hitting you with the
Yeah, Richard.
I'm not hitting you with the
Yeah, do what happened. You were like, oh yeah, you enjoyed it?
Mr. Douglas, I think someone asked a question. I heard like the ringing of the
Yeah.
Come here. Yes.
Peekaboo.
You're my book, I know, right now.
I need to clean my head every time that thing. That thing is dirty.
Oh, they're just saying hi to each other.
Oh.
Hi.
I can do that.
Sorry, you guys are welcome to do that. Not a problem.
You guys are getting
More rough.
fucking houses. I'm getting wild and nuts in here.
Woo!
It was
All right. So-
a child came in. It wasn't us.
Okay, so 9 times 27 is 243, I think.
You don't deserve
Yeah. 243.
How do you know that?
I did it earlier. I didn't know if I
Oh.
did. I said to check the last digit to make sure I got that.
What the heck?
No, I did it earlier. But 3 to the 5th is also 243. So you can see how that works. Now, here's the next principle. Okay? Okay. Yeah.
Why when you're doing that one, why doesn't 3 become 9 when you're multiplying 3 by 9? Because you're timesing it by the 9.
3 squared becomes 9.
No, I mean like when you 3 squared times 3 to the 3rd, wouldn't that become 9 to the 5th?
No, because your base stays the same.
Okay.
All you're doing is your exponents. And here's the proof for that, right? If you change this to 9 to the 5th, that's a much different number than this. But 3 times itself 5 times is 243. So let's look at another one. So we have the same concept. 3 real numbers, number A, and integers M and N. As long if A is not equal to 0, then you can do this. Stop. A to the division, A to the M divided by A to the N is just A to the M minus N. So with multiplication, you add exponents. With division, you subtract exponents. So, we'll look at an example. X cubed over x squared equals x to 3 minus 2 just equals x to the 1.
I'm not entirely sure why 5, but that's pretty easy to remember.
It is, it is easy. Yes, sir?
No, you're probably gonna answer my question.
But what happens if it's negative?
Yeah.
Yep, we're gonna talk about that. That's exactly right. That's the next thing.
Yeah.
So let me show you, but let's look at why this is true again. If you have x dot x, you remember doing this when you were younger in pre-algebra, when you were reducing algebraic ratios?
Yeah.
All you have left is an x. See how it works? It's reliable. Okay. Now, this is the one that freaked everybody out.
Wait, 1 second.
Okay, I'm ready.
Could you have a 3 with an exponent of 2 divided by 4?
You cannot you can, but you can't do the exponents that way. No, the only way you can do this, it has to have the exact same base.
Oh, okay.
That's crucial.
I think I've made it.
I'm not sure about your grade, but I know you're passing. All right. So having the same base is absolutely necessary for these things to work. You cannot do this with the bases different. If the base is different, then you got to do something else. Okay. You can work to get the same base. That's helpful. Matter of fact, I highly recommend that, but we're not there yet. So here's the next thing. So again, if A is not equal to 0, not equal to 0, I should say like that. As long as A is not equal to 0, A to the negative n is 1 over A to the n.
Nasty stuff on
So it's the same thing as this.
I'll get it off.
Sean and Catherine Lambert to the front office for checkout, please.
Tell me to stop on the back.
Catherine Lambert to the front
There's one
office
thing
for
that blew
checkout.
on me.
Don't do that.
I have a question.
Get it off my back now.
So this is if A is not 0, and that's also if A is not 0.
Yeah.
If
Yes.
A does not equal 0. That
Here, it doesn't matter. A could equal 0.
Right, but these are A if A doesn't.
But if A equals 0 over here, who cares, right? All you get is 0. But here, you can't have it. Now, why can you not have A equal to 0? If A was equal to 0, it would be in the denominator. You can't have 0. 0 raised to any power is just 0. Okay, less than thinking, hush.
For the bottom one right there, like the x over x. So the answer is just x.
Yeah, it's this answer here. I was just showing that. See, x cubed over x squared. X cubed is x times x times x. X squared is x times x. And you can cancel them.
Makes.
That's why it works.
Okay. So you don't have to put x1, you can just put x.
You just put x, yeah, that's right. I just showed the one to show that it's 3 minus 2 and minus 2. You don't even have to write all this out. You can do this and just give the answer. Just do this in your head. I don't care. Because you're just 3 minus 2. You know, most of you.
I have to write that out, I'm sorry.
Maybe I'll get a calculator if you need to, right? So now, a negative exponent does not make anything in the value negative. A negative exponent just pushes the base into the denominator. That's the thing that made everybody
They
upset.
were confused about that?
Wait, say that.
They're going to be so
I
lost
did-
in geometry.
I did
Say
that
that one more
first.
time, please.
A negative exponent does not make anything negative. It just pushes the base and exponent into the denominator.
Oh yeah, that's easy.
Great. I'm glad you think it's easy. I said it first earlier and they didn't like it and it confused everything. And then the rest of this was a real task. But, yes.
So, if, say, it was negative n minus another thing.
We'll do that. That's a good question. But that will help us. But let's start out with this. X to the negative fifth. Negative 5 is 1 over x to the fifth. Notice when you push it down here, it's not negative anymore. Now, here's how I want to show you why this is reliable. Okay? So what you're saying with this value, x to the negative 5 You're saying, is the value 1 over x to the 5th? Now let's try that with a number. 2 to the 5th power, negative 5th power, equals 1 over 2 to the 5th power, which is 1/32. That's the value of 2 to the negative 5. It is 1 over 32. That's the value, if you have to give the value. Okay? Don't worry too much about that. You're not going to do that very often. But that's how you would get it. Do you see what I mean? This number, 2 to the power of negative 5, this is it. It's this amount. It's not 32. It's not something else. It's not 10. It is 1 over 32. That's the value of this. Now let's see why it's true.
Okay, that's what I was asking.
Watch. So I'm now going to go back to this process. I'm going to do a different color. That will help.
So 132 is the value of 2.
1 over 32. 2 to the
1 over
negative
32 is the value of 2 over 2.
of 1 over 2/5 or 2 to the negative 5th. So let's watch. Let's see why this is true. So we're gonna go. Let me erase this. We're now going to go x to the 5th over x to the 10th. Now we know based on this that is x to the 5 minus 10, which equals x to the negative 5. And we've said that means that's 1 over x to the 5th. Here's why. You have this. Now, let's write an expanded form. One, two, three, four, 5. So if you were writing these out, because that's what that means. X to the 5th means x times itself 5 times. X to the 10th means x times itself 10 times. If you're writing those out, you write it out just like that, and you would start canceling. So up here you get 1, down here you get x, you get 1 over x to the 5th. You see how that worked out? Why can I hear someone's music again? Turn it off.
It's one of you
Somebody
three.
just turned it
One
off.
of you three.
It's not me, man.
It's not mine. You can't hear mine.
You'll do it.
Turn it off anyway. You got to pay attention.
I don't have to.
All right, so x to the 5th. Now here's another thing. Okay? So let's try this. Try this now with some numbers. Okay? We're now going to go back. And so I'm going to erase this stuff. Again, you can watch the video if you want. Erase this stuff. Now, we're going to go back and we're going to do this with numbers. 2 to the 5th over 2 to the 10th. That is, so we're going to give those values. 2 to the 5th is 32. I don't know what 2 to the 10th is. Anybody know? 2 to figure out?
10.
2 to the 10th power.
2 to the 10th, 2.
It's 1,024.
1,024?
Mm-hmm.
We have a visitor.
There's a car.
Hey, it's Kevin.
Hey,
Oh, yeah.
So,
Oh, yes. Okay, no.
now,
that's
watch
where you get
this.
2048 from.
32.
Oh, it is.
Hey, Nate,
Like,
I have a question.
10,
Did you get my question?
it'd be, 2 through the 11th would be 2048. Like, you know the game 2048?
Yes.
Oh my god. It's literally just 2 squared every single time.
Well, here, actually, before we do that, we could divide 32 into 1,024. We'll get a decimal. The other thing we do is reduce this. If we're going to reduce this fraction, you see this? Reduce this fraction, how's it going to reduce? Well, 32 goes into 1,024 how many times? Do that with your calculator.
What is it?
How many times does 32 go into 1,024?
5 times. I'm just kidding. 32.
Way more than 5.
20
times.
some. Is it really?
So it'd be 1/32.
Which is what we got there.
It's all coming together.
You see, it's just This is just showing, these are just shorthand ways to do this math. Exponents are really useful. They can save you a great deal of time. And the fact of the matter is you're going to receive many of your problems are going to come with exponents to begin with. Yes, Hayden.
I understand the 2 over, or the 2, 5, the exponent 5. I was confused on where you got the 2 10 from.
Oh, you just made that up.
I just made that
Made it
up.
up.
Oh,
I just made that up.
okay.
So I didn't see it like this one.
What it was.
X to the 5th over X to the 10th. So 2/5 over 2/10, or 2 to the 5th over 2 to the 10th is equal to 2 to the negative 5.
Okay.
Which is the same as that. I was just showing you how it works mathematically.
Okay.
The values work out when you put numbers in. But you will almost never have to worry about numbers because we don't care anymore about whether or not you can do arithmetic. We care about whether or not you can do real math, which means you've got to prepare for variables, a variety of situations. That's why we use variables. We use letters. I know, it's okay. Have you seen the meme that says, "What book made you cry?" and the person says algebra? So, anyway.
So the x to the negative 5 equals 1 over x5. So 1 over x5, is that the complete answer?
We sure do have it.
Yeah,
Yeah.
this is the answer.
Like adding up the numbers.
But here's the thing.
Okay. I love that.
So Kaylee just asked an important question.
Yeah, 'cause it makes sense.
Is this an answer? Okay. This is an answer, and it's the correct answer. However, you need to know that there's nothing wrong with this. The only time that you have to get rid of the negative exponents is if somebody says, write this in terms of a positive exponent. Now, there are certain parts of math where, for example, when we talk about radicals, okay, a radical symbol, you're not supposed to leave those in the denominator. So you got to radicalize and get rid of those.
We don't like that.
Some math teachers would probably say, I don't want to see a negative exponent. And when you get to your final answer, you should probably get rid of the negative exponent. But you're going to be doing a lot of work that keeping the negative exponent is fine. Because if you have the negative, so let's say I have x, a negative 5th, negative 5, times x cubed. Okay? Well, I can either switch those around and go, well, that means this is 1 over x to the 5th times x cubed, which equals x cubed over x to the 5th. And now I can do the subtraction and go 3 minus 5 equals x to the negative 2. Or I can just go negative 5 plus 3 is negative 2 and say x to the negative 2. So there's no need to push it down in the denominator except when you're asked. And so today you'll be asked on your assignment. When you're asked to rewrite this with a positive exponent, you got to do this.
Is our assignment due next Monday?
Yeah.
So where did you get the 2 from?
This 2? I just made it up. That was an example. Just an
Yeah.
example.
It was just an
Sorry.
example.
I picked it because I knew that 2 to the 5th was 32.
Okay, because
I
I've
wanted
been
to
sitting
use-
here trying to figure out how you solve that to get 2.
No, I wanted something since I did 5 here. I wanted the 5 there, but I don't know what 3 to the 5th is. But I know what 2 to the 5th is. So
Okay.
I don't know what 4 to the 5th is. But this is the only one I know, so that's why I picked it.
5th is 125.
Is it 125? That's right. No. Is it?
3 to the 5th?
Yeah, I have my own.
No.
5 cubed is 5 to the 3rd is
I did
125.
that reverse.
3 to the 5th is 240.
243. Oh, it's this. Oh no, we just did it. I did know what it was. I just forgot. Anyway. All right. So, the best thing for us to do is just to do a few of these together, and we're going to do your actual homework assignment together. The earlier class, everyone in the classroom finished it before they left. They were all worked up about it, but it's going to be terrible, and they all finished it before they left, so you will not take anything home tonight. But you can do this. It's really not difficult. I'm okay, by the way. Here's the deal. I gave you odds. I want you to do these problems. I don't want you to just write the answers down from the back.
Okay. So, if I know how to do this, do I have to go on and do that?
No, take off. I don't care.
Thanks.
I'm gonna show you the assignment. Oh, shoot. Oh, wait. Sorry. I'm jumping ahead. So you guys at home, I'm jumping ahead. Nope, we gotta do this. So there's other rules.
What? Is that gonna make me-
Oh, it's so ready. We're done.
I already know how to do it. Why would I learn it again?
If you already know how to do it, just a minute. Let me look this sign up.
It's the G from groove.
I really much easier for glasses.
They're laying,
Woo,
you're laying big brain
brain
more change. Yeah, that's funny. They're dead brain. What? I will literally dead brain now. You're no longer big brain. Or we've had a big brain.
You're excited no longer.
Big brain earlier.
Have you not used it?
Big brain.
Well, I don't even get to play.
No, I have a locker room.
I can't go to the locker room.
Maybe you're.
Why?
That's say a rule. If you're not playing in the game, you're not allowed in the locker room. You have to sit on the end of the bench away from everybody else.
Yeah.
And I can't wear my jersey.
Okay.
I can't wear my warm up.
You can't wear your warm-up?
That's
weird.
I was about to say,
I can wear TSCA like
Gear.
supporting my team, but I can't wear anything associated with basketball.
Is it the Monomials with Exponents?
Which is terrible because I'm a part of the team,
Amazing.
so I think I should be able to do that. I'm gonna sit there. I'm gonna keep stats and things. But I don't know.
Now, what if you have a power raised to a power? This happens a lot.
We have this.
This equals a to the m times n. So, if you have x squared raised to the 7th power, it's x to 14. So if it's the power of a power, you multiply. If it is the multiplication of bases to different powers, you add. But if it is a power raised to a power, you multiply. This is in your book, by the way, on page 257. So you can find it there. Now, so
You
that,
just made up the 2 and the 7, right?
yeah, I just made them up, yeah.
Yeah.
They're examples, just examples, yes.
If you had a squared times b squared to the power of 2, which one would you do first? The one on the side or the one for the exponent out? How I did that one time, thinking that was what I was supposed to do on the time of the
This whole thing to the power of 2?
Yes.
Okay, so
The
there,
whole thing by 2.
you have to distribute it. We're gonna look at that next. Let's look at that quickly and then we'll do it. So the power of a product. So that is AB to N equals A to N times B to N. The exponent, if it's outside parentheses, gets distributed. This is not the same as 3x squared. In that case, only the x is is the exponent. The 3 is not. But if you have this, sorry, excuse me. So this equals 3x squared. This equals 9x squared. Because this is the same as 3 squared times x squared. You take the exponent and you distribute it to each part of the term.
So that's an example of power of a product.
Yep. So we'll do, here I'll do another one. What about x times y raised to the 3rd power? Well, that's x cubed, y cubed. What about this is the example that Logan brought up. In this case, you have 2 things going on. You have the power of a product, so you have a squared. You have that separated because it's the power of a product. Then you have the power of a power, so now you have to multiply it so you get a to the 4th times b to the 4th. That's what you do. Does that make sense? Now, if you had, so let's suppose you had this. in this case, you can complete the parentheses first, right? And you whatever that would come out to be, 9 times 36. 312, whatever. So then you get like 312 squared. Right, which is a really big number. Or you can do this. You can go 6 to the 4th times 3 to the 4th and get your big number that way. You get the same number either way.
Wrong.
So there you do it. Well, you can do it right. You can mess it up too. Most of the time we don't do this. We're dealing with these. Now you will often have this. You'll have a coefficient, right? And then you got to cope with the coefficient. But you're not going to have that because this is nonsense. Why do that? It doesn't help me. So it's not nonsense. That's not true. It's just unnecessary. So now there's one other thing. If you have a over b to the n, that's the same as a to the n over b to the n.
Is this also PowerPoint?
What's that?
Is this PowerPoint?
It's power of a quotient. Sorry. I'll write that. I'll put that title. Power
I was about to say, I didn't think it was PowerPoint.
of a quotient. So it's a to the n over b to the n. So now here's where things get a little bit messy. If you have, so there's another part of that power of quotient rule. I'm going to do it up here. If you have a over b to the negative n, well, that equals a to the negative n over b to the negative n, which happens to equal b over a to the n to the positive n. It just flips them. If you have a negative, it just flips it. A negative exponent to this whole thing.
You say it's okay to write it as negative?
Yes, unless the question is asking you otherwise. If it asks you to write positive exponents, then you got to fix it.
Are we done?
Yes, let's look at the assignment. Oh! All right.
Only a few times have I heard you triple jump.
All right, so there's your assignment.
I'm not smart.
That's not so bad.
I'm going to jump. It doesn't take long. I'm going to jump on and I'm going to jump here right here in June 19.
Wait 1 second, please.
Well, let's do my best.
It's not.
This assignment's also in Google Classroom.
Since Emily's not here, you gotta give the answers.
Well,
That's been hard. You have to give the answers. Your friends are gonna help them out.
I don't know why I did that. Okay.
Somebody asked me.
I would give her the answers this year.
So these first few are quite easy.
19 to 40.
Odd.
Odd.
It's really not. It's not bad.
It's
at all.
fast.
How odd.
It's
I'm
really
already
fast.
halfway through.
Fast.
I wouldn't have assigned it if I didn't think you'd get it done in 30 minutes or more or less. Well, that's not true. Sometimes they will, but
Need the power of waiting for the right moment.
How come
Yeah,
last year, or what, I mean, actually not.
what's that?
Yeah, your assignments aren't too long.
I try to avoid them being too long. But this is one of those things that there are so many different options. If I didn't assign that many, you wouldn't have seen all the possibilities. So I needed to
Oh,
see.
don't you have to make sure, that Silas's book matches up with the time?
I did. By the way, Silas, I already checked your textbook today. And it matched it, I think. I have a copy of your textbook I found at home that is not like everyone else's textbook, but it's just like yours, I think, and it matched. So I'm trusting that yours matches too.
I just wanted to make sure you didn't forget.
So, all right. So here's 19. B squared times B cubed. So what do you all think that's gonna be?
Wait, what? That's not our book says.
For
Yeah,
19?
It's
Oh, B cubed.
it's B,
three.
Q
Sorry,
times B5, yeah.
Emily, you're face boosting us.
reading is not my forte. All right. I don't know what I looked at. There's nothing on my page that looks anything like what I wrote. All right, B cubed times B to the fifth. What is that?
D8. I'm kidding.
That's right.
Oh, I was thinking of multiplying them.
You don't want to multiply them. Yeah, this is the first homework problem. You add them. B to the eighth.
See, that throws you off though because there's a time symbol in between them. It's so easy. Yeah, it's easy. It throws you off though with time symbol.
But here's why it's true again. I'm going to show you again just because it's helpful. So it's B to the third times B to the fifth, which is B times itself 3 times, B times itself 5 times. You can remove these
But you just add it.
and you just count 1, 2, 3, 4, 5, 6, 7, 8, and it works. Yes, you can just add it. I'm just doing this to show you why it's true. Why it's true. All right. Now, this is of the other type. So, this is a power of a power. Power raised to a power. So in that case, you multiply them. So that equals m to the 9. 3 times 3. Now they're going to get a little bit messier. But I want you guys to try them. I am going to, I want to show you one other thing, because this was not part of our instruction, but it needs to be. So number 58. So you have some even one. 58. Y.
I'm gonna learn it on a separate paper because I'm not there. You have to.
28 equals y to the 3r times y to the 7. Now, you might look at this and think, how the heck am I supposed to figure this out? When have we ever had a variable? You got to solve this
Is
for
that
r.
say 3R?
Yes, it's
3R.
3R.
So there's a variable in the exponent, okay? Now, so what do you do with that? Well, let's first simplify this side. Y, so we can combine these because the base is the same. So this is y to the 3r plus 7, right?
Would it be 2R?
Yeah, wouldn't it be?
No, the base stays the same.
Oh.
A to the m times a to the n equals a to the m plus n. The base stays the same. The base does not change. If you change the base, it changes your value. So, but good question, and that's a common question. So now, if you just look at this, y to the 28 equals y to this. In order for this to be true, what does this have to equal? It's got to equal 28, exactly. And so all you got to do is do 28 equals 3r plus 7. You can take the y's out because the y's are meaningless when it comes down to this. So you can do minus 7, 21 equals 3r, 5 by 3, and r equals 7. Wow! So, now,
So then do you just plug that back in?
you don't have to, you're done. You got r, that was your job.
That's all you have to do?
Yeah.
You just have to get R by itself. Yeah.
Now, here's the thing.
Right, Mr. Douglas? R by itself?
When you get into, yes, get r by itself. When you get into pre-calculus, I don't think we're going to do these here. We might do it at the very end of the year. But you can do logarithms and you can start finding these things out with less information even. You can start discovering exponents with less information. So it's kind of fun. That's what pre-calculus is getting ready to do that. They don't know that it's fun yet, but it's going to be. Did all you guys stay up last night watching basketball or something? Watching basketball?
I mean,
Both of them are asleep.
I know.
I went to
Hold on.
late, but I'm not one that's not falling asleep.
Okay.
They're tired.
I am entirely opposed to doing this, and yet I'm going to do it anyway. Never. Oh my gosh, she didn't even wake up.
Here's the music.
Hit him with it. Hit him with the broom. Hit him with the book. Oh, well, that's nice.
That's a good choice. Good taste, good music.
Turn it up.
That's so legendary.
Play some really like weird music so he wakes up. Here, I'll fart on him. I'll fart on
Okay,
him.
so,
No, we're still.
Oh my gosh.
oh. Did I stop sharing the screen?
Okay.
I'm sorry, guys. So you guys have the assignment?
Fart in that. We worked on that.
You're not
Should
listening.
I fart in the mic? Yes.
Who stopped this?
Ow. I'll pull a David.
They fall back to